Okay, so some information you need to know when you graph the sine and cosine function. First of all, the equation is going to look something like this. This number here in front of the sine is what's called the amplitude. And the amplitude is how high or low you are based on, we'll be using the x and y axis. So how high up on the y axis or on the lower part of the y axis. This number b here is used to figure out exactly what the period is. The period of the sine curve, if you type it into your calculator, you're going to see this function and it keeps on going and you don't know where it stops and where it ends. But we define one period as to be one complete rotation of the curve, and then you see it repeats again and again and again. Both ways. So type that into your calculator and see what it looks like. So we use the b to find the period because the standard period is 2 pi. So 2 pi over b gives you the exact spacing for one complete picture of the sine curve. Let me do a real number example for you. All right, suppose I give you y equals 3 sine, let's fix that again, 3 sine 4x. What that means is the amplitude is 3 and the period is 2 pi over 4, which is pi over 2. These are key points when I'm doing a sketch of the sine curve. Now what I like you to do is draw your x and y axis like this, and we're going to just sketch one period of the sine curve. Since the amplitude is 3, it means that it has a high of 3 and a low of -3. It's going to span up and down. Now, remember we said the sine curve looks like this? So now I'm going to sketch one complete cycle of the curve. Now, it does go on and it keeps repeating this cycle. When you do a sketch for me for the homework, I'm going to tell you to sketch one period. Sometimes I'll tell you to sketch 2 periods. But I need some numbers across here because I want to know what are the values in terms of degrees of the sine curve. Now, the standard is 2 pi. So if I said graph y equals sine x, the sine curve would have an amplitude of 1 to -1, and we'd have the complete sine curve, and it would end here at 2 pi. So I like you to have 4 divisions when you set up your graph. So half of 2 pi would be pi. Half of that would be pi over 2. So if I count now, 1 pi over 2, 2 pi over 2, which is the same as pi. This one would be 3 pi over 2. This would be 4 pi over 2, which is 2 pi. That's the standard sine curve. We're graphing y equals 3 sine 4x. So here, instead of going up just to 1, we're going up to 3 and down to -3. We have our sine curve. Now, where is the end point for this? In the standard, it ends at 2 pi. But ours, we did 2 pi over 4. Because of that 4, that's the b. So pi over 2. So my curve here ends at pi over 2. Now the hard part, figure out what these other divisions are. I like to do halfway first. So what's half of pi over 2? So do 1 over 2 times pi over 2. How about pi over 4? What's half of pi over 4? Because now I want to do halfway again. 1/2 times pi over 4 would be pi over 8. And then I count 1 pi over 8, 2 pi over 8, which reduces to pi over 4. This one is 3 pi over 8. This would be 4 pi over 8, which reduces to pi over 2. So it's really a nice, easy counting once you figure out where your end point is. So the important things when you graph, find the amplitude, find the period, and know what the sketch of the sine curve looks like. So the sketch of the sine curve. There we go. All right, let's do one more. Suppose I have to ask you to graph this. Y equals minus 3 sine 5x. All right, I know the curve I'm doing the sine curve, and the general sine curve looks like this. Normally the period's the amplitude is 1 to minus 1, and the period is 2 pi. But in this one, I have an amplitude of -3, and the period is always 2 pi over b. In this case, the b is 5. So my full sine curve ends at 2 pi over 5. All right, so let's get a little sketch here. I go up to 3, down to -3. And I'm going to end at, let's see, normally I end at 2 pi, right? So that would be pi, 2/5 pi. So I'm going to stretch this out. So this is not going to be to scale. We're going to put our end, and we'll call this 2 pi over 5. So that's where our curve has to end. Now I have to sketch the sine curve in here. But because we have a minus here, it's upside down. So I go down first. So I'm going to try to balance it. If that's 2 pi over 5, there's a halfway point, and I want the quarter points because that's going to be enough to label it. So the sine curve upside down, and then there's the last part. And again, remember, these continue on forever. I just want a sketch of one period of it. All right, so I know that it has an amplitude is really absolute value of that number. So the amplitude is 3. It goes up 3, down 3. But because it's minus there, it goes down first. All right, let's find these divisions. Remember? Halfway. So halfway. What's half of 2 pi over 5? If you can't figure it out, just do 2 pi over 5 times 1 over 2. What do you get? Pi over 5. Okay. So this is pi over 5. Let's do half of it again to get this one. Pi over 10. 1 pi over 10. 2 pi over 10. 3 pi over 10. 4 pi over 10. All right, let's do one graph of the cosine curve. Suppose I have this. Y equals 4 cosine 2x. And I want to graph that. Well, first of all, I need to know what the standard cosine curve is. And so the standard cosine curve is this curve here. It's really the sine curve offset by 90 degrees. And the standard goes up to 1, down to -1, and ends at 2 pi. And so the divisions are pi over 2, 3 pi over 2. But we're doing a variation of it. Again, identify the amplitude. The amplitude is 4, and the period, just like when we did the sine curve, it's 2 pi over b. In this case, the b is 2. So the period is pi. So this whole sine curve is going to take place, instead of in 2 pi, now in pi. If I sketched it right on here, you'd see it would kind of be scrunched together like this. But we're going to stretch it out a little bit. But it's the same curve. It's just squished up into the space of pi instead of being stretched out over 2 pi. These values are important. And not only is it scrunched, but it's stretched up to 4 and down to -4. So we'll do a sketch, and our sketch won't be to scale, but it will show all the proper divisions. All right. So what did we say the amplitude was? 4. 1, 2, 3, 4. 1, 2, 3, 4, -4. And we always need 4 divisions. 2, 3, 4. This one's going to end at pi. What's halfway of that? Pi over 2. What's half of that? Pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi. I always check. Once I get this one, I check by adding a quarter of each thing as I go along. All right. Now I know I'm doing the cosine curve, which starts high, right? And then it's going to end high. It's going to end there. It's going to cross over here. It's going to cross over here. It's going to have its low point down here. All right, so let's sketch it in there. There you go. Again, if you're sketching something that has a negative in front of it, I go down first. I think you can do the homework now.